Hey everyone, and welcome back to the channel. Have you ever wondered about the simple magic of a soap bubble? We see them everywhere in the bath, while washing dishes, or just playing in the park. They float, they shimmer with rainbow colors, and then they pop. But what exactly is happening? How does a simple bar of soap or a bit of dish liquid create these amazing, delicate spheres? Well, today we're really going to dive deep into the science behind bubbles and uncover the secrets of how soap works its magic. It's a fascinating journey into chemistry and physics that's happening right in your kitchen sink. So, to understand bubbles, we first need to talk about water. Water molecules are like tiny magnets. They really like to stick together. This attraction is called surface tension. Imagine a bunch of people holding hands tightly in a circle it's tough to break through. That's what water molecules do on the surface. This strong surface tension is why water forms beads or droplets instead of spreading out flat. It is also why it's actually pretty hard to make a lasting bubble with just pure water. If you try, you might get a tiny, fleeting bubble, but it will pop almost instantly. The water's surface tension is just too strong and pulls the water molecules back together, collapsing the bubble. This is where soap comes to the rescue. Soap molecules are really special. They have a unique two-part structure. Think of them like a tadpole with a head and a tail. The head loves water it's hydrophilic, but the tail, it hates water it's hydrophobic. In fact, the tail would much rather be next to things like oil, grease, or even air. When you mix soap with water, these tadpole molecules get to work. They arrange themselves in a very clever way. The water-loving heads stay in the water, but the water-hating tails poke out, trying to get away. Now, let's make a bubble. When you blow air into a soapy water film, you're creating a thin sheet of water. The soap molecules immediately line up on both the inner and outer surfaces of this sheet. Their water-hating tails point away from the water out into the air on the outside of the bubble, and into the air trapped inside the bubble. Their water-loving heads stay pointed inward towards the water layer. This creates a sandwich-like structure. A thin layer of water is trapped between two layers of soap molecules. This soap and water sandwich is the secret to a stable bubble. The soap molecules weaken the water's surface tension. They get in between the water molecules, making it so they can't hold on to each other as tightly. This allows the water film to stretch without breaking, kind of like adding elastic to a piece of fabric. This new, lower surface tension makes the film flexible and strong enough to form a sphere, which is the most efficient shape for holding a certain volume of air with the least amount of surface area. And that's your bubble. It's a delicate pocket of air, protected by a flexible, soapy shield. But why do bubbles pop? Well, a few things can happen. Gravity is constantly pulling the water downwards, making the top of the bubble thinner and thinner. Eventually, it gets too thin and breaks. Also, evaporation plays a big part. The water in the bubble's wall can evaporate into the air, which also thins the wall. Finally, if the bubble touches anything dry, like your finger, the dry surface will absorb the water from the bubble's wall, creating a hole and causing it to pop instantly. However, if your finger is wet, you can often touch a bubble without it popping. And what about those beautiful rainbow colors you see swirling on a bubble's surface? That's a phenomenon called iridescence, caused by the reflection of light. As light hits the bubble, some of it reflects off the outer soap layer, and some of it travels through the water layer and reflects off the inner soap layer. These two reflected light waves interfere with each other, canceling out some colors and amplifying others. Since the bubble's wall is constantly changing in thickness due to gravity and air currents, the colors you see are always shifting and swirling. It's a beautiful light show on a microscopic scale. So, the next time you're washing your hands or see a child blowing bubbles, you'll know the incredible science at play. It's all about water, surface tension, and the amazing ways soap molecules can manipulate it to create something so simple, yet so beautiful. It's a perfect little bubble of physics and chemistry floating through the air. Thanks so much for watching and exploring the science of bubbles with me today. If you enjoyed this video and learned something new, don't forget to hit that like button and subscribe for more curious adventures. See you in the next video.